Hello class, I am teacher Iwa Moses, a teacher of chemistry from Grace High School. Today we will be sharing about fossil fuels. As we can see in the picture here, we have some pictures related to what we shall learn from this topic. We want to look at the topic. We have the keywords that we are supposed to be understanding in this chapter. One of the keywords is crude oil. We have coal, natural gas, petroleum, sedimentary rocks, fossil fuels, carbonization, anaerobic decay. So those are some of the words that you should make sure that by the end of this chapter you have understood. Our learning outcome mainly in this chapter is that by the end of the chapter, as a learner, you should be able to understand the types and origins of fossil fuels and why they can be used as sources of energy and useful materials. I want to start by looking at this question here. What are fossil fuels? So if you're the person who has been asked that question, what will you say? When you look at fossil fuels, we say that fossil fuels are natural substances formed from anaerobic decay of dead plants and animals that lived millions of years ago and are used as a source of fuel. So when we look at this definition, the phrase that natural substance, it means that the fossil fuels are not made by man, but they exist naturally. These are things that God has already put in place. And then the time of formation, I have said here that it is formed over millions of years ago. So the fossil fuels are formed from the dead plants and animals, and it is an emphasis here that these animals and plants lived millions of years ago. These organisms decompose under high pressure and temperature over a period of millions of years ago and were converted to crude oil, coal, and natural gas. So these three are the different types of the fossil fuels that can be got naturally. So they are got from the remains of plants and animals after they have decomposed. The process of decay occurred in deep layers inside the earth and has taken billions of years. So this one tells us that since when you look at the time of formation, it takes long for a fossil fuel to be formed, and it emphasizes that these fossil fuels are non-renewable resources. Because of the time of formation, it is not easy to sustain this. They are formed over a longer period of time. As we have mentioned here that the fossils are converted to crude oil, coal, and natural gas. So we have one of the types of the fossil fuels is crude oil. So crude oil can also be known as petroleum, and this is the most common fossil fuel that you might be familiar with. The word petroleum is derived from the Latin words petro, which means rock, and lium, which means oil. And we want to look at in detail the types of the fossil fuels. As we have mentioned earlier, there are three types of fossil fuels. So one of the types is crude oil. Crude oil is a thick, darker brown or blacker liquid. So we are saying crude oil is a thick, darker brown or blacker liquid. As we can see in the picture here, that's the appearance of crude oil. And then natural gas is a colorless gas, just like any other gas. It cannot be seen, but this picture here shows us how it burns. So it burns with a blue flame. Let's look at the formation of those two first of all. Formation of crude oil and natural gas. These two are formed together in the same process and are found together. So what happens is that plants and animals die and become buried at the bottom of the ocean with layers of sand and silt. After millions of years, and after more and more layers of sand and silt or sediments become deposited on these remains of organisms, they become buried deeper and deeper. Then these remains become compressed under high pressure and heat due to the weight of the layers and are converted into oil and natural gas. So I want to emphasize something here. In senior 1, when you learned about rocks and minerals, one of the types of rocks you learned about formation was sedimentary rocks. So these sedimentary rocks are formed in oceans. So you find that the small rock particles are washed by water, running water during erosion into a water body. Those small particles of rocks, they end up being deposited to the bottom of the ocean. You also find some plants and animals inside the ocean. So when those plants and animals die, their remains or their fossils also sink to the bottom of the ocean. So those things all together end up being buried down deeper at the bottom of the ocean. And after more and more of them have been deposited on top, as you have said here, the pressure from the weight of those ones above increases, and also the temperature. So after millions of years, the buried fossils will be converted into either crude oil or natural gas. So that's how those two types of fossil fuels are formed. The third type of the fossil fuels is coal. Coal is a black rock-like solid. So as it can appear in the picture here, you may just assume that this is charcoal, but no, this is coal. The formation of coal, coal was formed by the action of heat and pressure on the remains of trees and plants on land over millions of years. So mainly, coal is formed from the remains of plants or trees. But when you look at crude oil and natural gas, we say they are formed from the remains of plants and animals. So coal is purely formed from plants or the remains of what? Of plants. So that's about the formation. But the difference is coal is formed mainly on land when these trees are decomposing, and then fossil fuels like crude oil and natural gas are formed in water, in oceans during the formation of a sedimentary rock. So they are always found below or under the sedimentary rock or in the sedimentary rock. The next thing we want to share here is how the fossil fuels are extracted. So we want to look at first of all this picture here before I emphasize on how the fossil fuels are extracted. So let's take a time as we watch this video. Let's watch the video.
Once the surface section of the well is drilled, the drill pipe is pulled out of the hole in order to lay the casing. This is done for environmental reasons to hydraulically seal the formation layers containing aquifers from the flowing hydrocarbons later on, once the well is completed. The casing string is made of numerous joints the same size screwed together at the collar. The casing pipe is selected according to its outer diameter, its wall thickness, its length, its weight by unit length, and the grade of steel it is made of. The selection of grade of casing depends on several variables, including the size of the hole, the rugosity of the drilled hole, the expected pressure of the flowing hydrocarbons, the H2S content, as well as the economic considerations. Once the entire weight of the casing string is solely suspended by the hangers, the casing is considered laid in place. In order to secure the laid casing string to the formation, cement is pumped through the casing shoe at the bottom of the well, letting the cement flow between the casing and the formation. To allow further operations in the well, the cement requires sufficient curing time. Once the cement has dried, the seal of the aquifers would be established. The drilling then continues through the wiper plug, the casing shoe, and the cement at the bottom of the hole until the desired depth is reached. This is called total depth, or TD, and is where the pay zone is anticipated. To evaluate presence and economic feasibility of this pay zone, the drill pipe could be equipped with logging while drilling tools to evaluate formation while drilling. It is a common practice to lower wireline logging tools to evaluate the formation and determine the economic feasibility of the drilled well. This is done by logging the anticipated pay zone through various types of sensors to determine the key properties of the zone. After the pay zone has been determined and deemed feasible, the wall needs to be prepared to extract the discovered hydrocarbons. This process is known as the completion of a well. A common completion method requires inserting a casing string into the newly drilled open hole to prevent the borehole wall from caving prematurely during the various steps of completion. To allow further operations in the well, the cement requires sufficient curing time. The cementing process is not always a flawless operation, and the resulting cementing job might contain some bonding issues that would undermine the strength and integrity of the casing, especially during perforation. The bond of this cement with the formation and with the casing is evaluated using a cement evaluation wireline tool. This tool determines whether the cement job is optimal. If not, further remedial operations are required. To establish a path with the hydrocarbons stored in the pay zone, a perforating gun is now lowered to the target depth. Wireline is the preferred conveyance method for short and light gun strings. To deploy long and heavy gun strings, a technique referred to as tubing conveyed perforating, or TCP, is required. Using sensors part of the gun string, the guns can be accurately positioned in front of the targeted reservoir. The charges in the gun are now ready to be ignited using the surface perforating control equipment. Once the correct depth has been confirmed, the gun is fired. The charges in the gun explode, providing a path through the formation, the cement, and the casing to the production tubing. The perforating gun is then pulled out of the hole. Now, the well is perforated and the path has been established between the stored hydrocarbons and the wellbore. While the drilling rig is still in place, production tests are performed to confirm the commercial viability of the reservoir before the production string is installed in the well. A typical production string is made of a tubing string that includes a packer near the bottom end. The production packer is installed above the top of the perforations to ensure that the flowing hydrocarbons reach the surface only through the production tubing. Before the drilling rig is dismantled and moved away to its next location, the wellhead equipment, commonly referred to as the Christmas tree, is installed on top of the well. With the well completed, the production of hydrocarbons can begin. These hydrocarbons will fill storage tanks or feed pipelines until the day when the production rate has diminished and the well is plugged and finally abandoned.
Thank you very much for coming back from that video. So we have been looking at ways of extraction of fossil fuels. Let's wrap it up. When you talk about extraction of fossil fuels, there are two main methods for extracting fossil fuels from the ground. That is mining and drilling. So the method we have been looking at under the video was a drilling method. So the fossil fuels are obtained from the earth by mining and drilling. Mining is the extraction of solid fossil fuels from the earth. So an example can be coal. Coal is extracted by digging underground or scrapping from the surface. So for the case of mining, we use it to obtain coal. And then the drilling method, it cuts across, is a cutting process in which a drill bit is used to cut or enlarge a circular hole in a solid material. Crude oil and natural gas can easily be forced to flow to the surface using the drilling method. So you can re-watch the video and see more. So the method that has been shown in the video is the drilling method, how we can obtain crude oil, or how we can extract the crude oil and natural gas, as it has been well explained. So that is about extraction of fossil fuels. I would like you to take this assignment as you wait for the next lesson or in the next episode. The first question is, why are fossil fuels used as a source of energy? So I want you to research about this question. And then question 2, what are the uses of the fossil fuels? Number 1, crude oil, natural gas, and coal. What are the uses of these fossil fuels? So that is our lesson for today. I want to say that we have come to the end of the lesson. I thank you for your active participation. See you in the next episode. Have a nice day. Bye bye.